Hello everyone, in this lecture we want to discuss about logistic regression and theory behind it. The main feature of this regression method is for classification of some categorical variable. So logistic regression or logged regression is a regression model where the dependent variable is categorical. In this case, a binary dependent variable can take only two values, 0 and 1, which represent outcomes such as pass or fail, win or lose, alive or dead, or healthy or sick. Cases where the dependent variable has more than two outcome categories may be analyzed in multinomial logistic regression. Logistic regression was developed by a statistician David Cox in 1958. The binary logistic model is used to estimate the probability of a binary response based on one or more predictor or independent variables. An explanation of logistic regression can begin with an explanation of the standard logistic function. The logistic function is useful because it can take any real input t, whereas the output always takes value between 0 and 1, and hence it's interpretable as a probability. The logistic function sigma t is defined as follows. Sigma t equals to e to the power of t divided by e to the power of t plus 1. Or you can write it 1 divided by 1 plus e to the power of minus t. And as you can see, the value of sigma t is between 0 and 1. And you can print this figure if you set a range for t and print it in your calculation programming method and software. We can define t as a function of x as follows. T equals beta 0 plus beta 1 multiplied by x. Now we can define logged function. It is inverse of logistic function. So g is a logged function and it's equal to natural logarithm of f(x) divided by 1 minus f(x). And as you see, f(x) is equals to sigma t or logistic function. And all of this natural logarithm is equal to beta 0 plus beta 1 multiplied by x. To find odd, this function f(x) divided by 1 minus f(x), this is odd function exponentiating both sides. And as you can see, f(x) divided by 1 minus f(x) is equal to e to the power of beta 0 plus beta 1 multiply x. In this equation, the terms are as follows. G is the logged function. The equation for g f(x), it illustrates that the logged is equivalent to the linear regression expression. ln denotes the natural logarithm. f(x) is the probability that the dependent variable equals a case given some linear combination of the predictors, resulting expression for the probability f(x) range between 0 and 1. Beta 0 is the intercept from the linear regression equation, the value of the criterion when the predictor is equal to 0. Beta 1 multiplied by x is the regression coefficient multiplied by some value of the predictor. Base e denotes the exponential function. So to create logistic regression, we need to find beta I or logistic regression coefficients. To do this, we use maximum likelihood method. The regression coefficients are usually estimated using maximum likelihood estimation. Unlike linear regression with normally distributed residuals, it is not possible to find a closed form expression for the coefficient value that maximizes the likelihood function, so that an iterative process must be used instead. For example, Newton's method. This process begins with a tentative solution, revises it slightly to see if it can be improved, and repeat this revision until no more improvement is made, at which point the process is said to have converged. Now we discuss about some applications of logistic regression. Logistic regression is used in various fields, including machine learning, mass medical fields, and social science. For example, you can classify some variables in machine learning by using logistic regression, or the trauma and injury severity score TRISS, which is widely used to predict mortality in injured patients, was originally developed by Boyd et al. Using logistic regression. Many other medical scales used to assess the severity of a patient have been developed using logistic regression. The technique can also be used in engineering, especially for predicting the probability of failure of a given process, system, or product. It is also used in marketing applications, such as prediction of customers' propensity to purchase a product or hot subscription. In economics, it can be used to predict the likelihood of a person's choosing to be in the labor force, and a business application would be to predict the likelihood of a homeowner defaulting on a mortgage. Conditional random fields, an extension of logistic regression to sequential data, are used in natural language processing or NLP. So I think we discussed enough about background and theory behind logistic regression, and now we can go to coding some program to examine our knowledge and calculate accuracy of our method and our classification method based on logistic regression. So stay tuned to the next lecture, and thank you.